Okay, we're going to continue with our titration, and we're at 25 milliliters. So actually, let's lower this down a little bit. We're probably down to here right now. My eraser isn't working, so that's not quite as nice as it used to be. But anyway, we're at 25 milliliters of OH minus added, 0.1 molar NaOH, into 25.0 milliliters of 0.1 molar acetic acid, which I'm designating as HAC. So we're going to put in 2.5 millimoles, remembering that molarity times milliliter is equal to millimoles. And when we get to this point, we have no limiting reactant. We're going to lose 2.5, lose 2.5. And at this point, we can't use Henderson-Hasselbalch. We only have 2.5 millimoles of acetic acid or acetate in water. Now, what's going to happen? Well, this is why I stored our little Kb up here. At this point in the titration, we no longer have any acetic acid left. So we're at the equivalence point, and what happens is this stoichiometry chart flips over and becomes an ice chart, and it's a Kb. So we have 2.5 millimoles of acetate in water. Now, if we want to run this reaction, so we can't use Henderson-Hasselbalch because our acetic acid is gone, and so I'm just going to get rid of that right now. Just delete it. There it goes. And now we're going to take our 2.5 milliliters. We need to change it into concentration because when you use an ice chart in an equilibrium, it's always in concentration. So we need a concentration of acetate, which will be, in this case, 2.5 millimoles over a total volume, which is 25 plus 25. So we're going to use 50 milliliters in the denominator. And so that'll be 0.050 molarity. And now we're at the ice chart. Whenever you have water on the left, it's an ice chart. Whenever you have strong on the left, it's a stoichiometry chart. So 0.050 minus x, squiggly, x, and x. And we already calculated our Kb here. So Kb is 5.6 times 10 to the negative 10th. So we have x squared over 0.050 minus x is equal to 5.6 times 10 to the negative 10th. And once again, we can get rid of x because x is small compared to 0.05 because Kb is very small. And when you're done with that, your x is equal to OH minus. So when we're done with that, I'll look up my value because I've already punched it in, is 5.29 times 10 to the negative 6th. So your POH will be between 5 and 6. So POH is 5.28. And pH is equal to, at this point, 8.72. It better be greater than 7 because we have a base in water. So 8.72. Now, so remember, at the equivalence point, you have to flip and use Kb and use an ice chart. And remember, with an ice chart, you have to use concentration and not stay in millimoles. Now, we'll go on to the next step. When we go beyond the equivalence point, let's clean up our workspace one more time. Again, the only thing that changes is the OH minus. 2.5 always stays the same. So now we have 4.0. Now our limiting reactant becomes the acetic acid. We're going to lose the acetic acid, go to 0, minus 2.5, and then plus 2.5. And you're done with 2.5 here and 1.5. Now, the amount of OH minus that comes from acetate is diminished because of Le Chatelier's principle, because we have OH minus in solution. And so you're not going to get additional OH minus from the acetate. all of the OH minus concentration comes from the concentration of OH minus in excess. So your pH is dependent only on this number right here. So once again, we have to go to concentration and look at total volume. So you have 1.5 millimoles of OH minus over a total volume, which will be 40 plus 25, which is 65 milliliters. And when we plug that in, our value here is, well, I don't have that calculated, but I do have the pH. The pH is, at that point, is 12.36. So what you should do is make sure I got that right and plugged it into my calculator. It makes sense. It's 12.36. So that completes our titration. And now what we're going to do in the next video is actually look at what it looks like when we graph this video, this set of data.